Okay, so we are Team 23 and we chose the Energy Efficiency Predictor Project. My name is Marina
Oh, and I'm Caleb.
and I'll just be explaining some things. The importance of HVAC efficiency plays a crucial role in homeowners' energy consumption. Minimizing the energy consumption of HVAC is a challenge in that a homeowner's HVAC has a lot of variance to it and the solution can differ by its circumstances. The database contains information such as the dimensional presence of the heating and cooling system in residential housing. Furthermore, it contains information pertaining to the area of which the system glazes and the load that it contains.
And now moving on to the data model itself, we'll be talking about the code as well as the documentation. Here we simply import all the libraries that we need throughout the code, and we start by reading the script, the CSV file. Then we move on to data processing. We go ahead and define x, y1, and y2. Then we take, then we go ahead and sorry. Nah, Then we go and split the data into training modules and testing sets. Train for X, train for test for X. Then we take the training for heating and the test for heating, and we split that into X, Y1, and then we go ahead and move on to X train, X test again, and then we train for the cooling and test for the cooling. Then we move on to initializing the random forest models for heating and cooling load prediction. We say the model heating is equal to the random forest regressor, where we take n estimators of 100 and a random state 42. We do the same similar thing for cooling. Then we move on to step 4, where we train the models by fitting them to the X train as well as the Y training heating. Then we do a similar thing for the cooling. Step 5, we evaluate the models where we predict the heating as well as the cooling. Then we assess the model's quality using the MSE and two-dimensional score. MS heating is equal to the mean squared error with the test heating and the predicted heating. And then the two-dimensional heating is the R squared, the two-dimensional score of the test heating and the predicted heating. And we do a similar thing for the cooling here, and then we print that out at the final as the output. Then for step 6, we input data interface. So here we go ahead and to predict the heating loading and the cooling loads. We define a function called predict heating cooling, and we give the parameters of the x through 1 through 8 columns of the data frame. Then we create a new data frame with the inputted data, and we predict the heating and cooling loads using the trained models, giving us the return value of the heating load prediction and the cooling load prediction. Then we take step 7, where we go to we test the predictions for 3 feature combinations. Feature combinations where we go ahead and do a inputted, which we can change how necessary to go ahead and input into and see how the results would vary. Then we get predictions for each combination, where we would say for IDX features in the enumerator of the feature combinations. And we take heating and cooling, and we do the prediction, heating, cooling. And we go ahead and print out the F combination, where we print out the combination for the heating loading. We represent for each combination which we choose, we can vary as the input, and we say the heating loading and the cooling loaded that was predicted for the values. The predicted heating and cooling loads from the data model represent values relatively similar to the ones of the actual data that we saw in the data model that we originally started with, which represents the successfulness of the prediction. Thank you for listening.